Hi, hello everyone, good evening all. How are you all doing? I hope all are doing well. Anyway, a warm welcome all of you to the YouTube channel of Infinity Learn by Sri Chaitanya. This is me Surya, your chemistry mentor for this particular chapter. Okay. Hi, hello. Okay, in this particular session we are going to discuss the new chapter, that is chemical bonding and molecular structure. In your examination point of view, as well as JEE Mains as well as JEE Advanced, this is a very important chapter. Okay, let us see what are the main weightage of this chapter. Okay, as you can see here, this is the weightage of these concepts, about 59% in our JEE Main exam. These are the major concepts we are going to discuss in the particular chapter. As you can see, this is the Lewis impulse and octet rule, formal charge, bond parameters, PSEPR theory, VBT, hybridization in MOT. Today in this session, I will going to discuss these particular chapters and these particular topics, that is Lewis impulse and octet rule. And finally, we are going to discuss about the formal charge also. Let us start. Okay, here is the first topic, that is the what do you mean by a chemical bond? What does come in your mind whenever you are hearing about the chemical bond? Something related to the combination, right? Chemical bond means something related to combination. Whenever any atoms or ions that combine together to form, there will be the attractive forces as well as repulsive forces, right? Then the magnitude of attractive forces are very high as compared to the magnitude of repulsive forces. The type of attractive forces which is existing between atoms or ions in a molecule is known as the chemical bond. Okay, what do you mean by the chemical bond? This is the attractive force which holds various constants, either atoms or ions, together in different species. Together in different chemical species is known as the chemical bond. Clear? Okay. As you already aware about the types of chemical bonds, right? What are the different types of chemical bonds? Yes, ionic bond and covalent bond are the two types of chemical bond. As you already know about that, what do you mean by the ionic bond? These are the chemical bond formed between the atoms or ions by the transfer of electrons, right? Transfer of electrons. Then what about the covalent bond? There will be the mutual sharing of electrons, right? The bond that formed between the atoms or ions by the mutual sharing of electrons are known as the covalent bond. Clear? We will be discussing about the ionic bond and covalent bond detail in our next sessions. Now let me move to the major part of this particular chapter, that is the Kossel-Lewis approach to chemical bonding. What do you mean by the Kossel-Lewis approach to chemical bonding? As already know that the Lewis, one of the scientists, he pictured the atom in terms of a positively charged kernel, which means nucleus as well as the inner electrons. A positively charged kernel including the nucleus plus the inner electrons, and the outer electron shells or outer shell that accumulate maximum of 8 electrons. For example, if I am taking a sodium atom, this is our sodium atom, right? Having the atomic number of 11, which means its electronic configuration is 281, because it has the valence electron of 1. If I am drawing the picture of a sodium atom, I can draw like this. This will be our nucleus. This will be our first shell having 2 electrons. Then what about here? In the second shell, it is having 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Then the last electron, that is known as the valence electrons, found in the outermost shell known as the valence electrons. So this will be the structure of Na atom or sodium atom. As I already mentioned that the outer shell electrons are commonly known as the valence electrons. So I can call this electron as a valence electron. Then what about the inner shell electrons? These inner shell electrons are known as the core electrons. Then according to Lewis, he explained that The core electrons plus nucleus constitute the kernel. The core electrons plus nucleus constitute the positively charged kernel. Clear? Now again Lewis postulated that in order to achieve the stable octet, atom will form chemical bonds. What the atoms are going for chemical bond? In order to attain the stability or to attain the octet configuration, which means the outer electrons must have the 8 number of electrons, that is known as the octet. Finally, he proposed a rule known as octet rule. What do you mean by the octet rule? This octet rule was proposed by Walter Kossel and Gilbert Newton Lewis. That is why this rule is also known as Kossel-Lewis Approach. Okay, what he has discussed about that? This octet rule was based on the electronic configuration of noble gases. For example, if I am taking any example of noble gases, if I am taking the neon, what is the atomic number of neon? 10, right? Which means it contains 2 8 electrons. Its valence electron is 8, that is octet electrons. It will have the stable octet configuration and it does not undergo any chemical reactions. That's why octet rule is based on the electronic configuration of noble gases. Now, what is the exact definition of octet rule? It says that the atoms of various elements enter into chemical combination or forming into the chemical bond in order to have an octet in their valence shell to attain stability. What is the major concept of octet rule? In order to attain the stability or to have the octet electronic configuration, they will form the chemical bonds, right? This is known as the octet rule. Clear? Fine. But there is again exemptions are happening. If you are taking hydrogen or helium, if the hydrogen is forming molecule, H2 molecule, it will contain 2 electrons, right? Then what about the helium? Helium is a monoatomic molecule. It will again contain 2 electrons. But it is already stable, right? That stable configuration is known as the duplet configuration. What do you mean by the duplet configuration? The atoms which have only 2 electrons in their valence shells are known as the duplet configuration. This is against the octet rule, which means that in the duplet configurations also it has the stability. Clear? Then, in order to achieve the octet electron configuration or to get the stability, the atoms are undergoing either sharing of electrons or transfer of electrons. They are forming the bonds. If they are forming the bonds by mutual sharing of electrons, the bond is known as the covalent bond. And if the bond is formed by the transfer of electrons, that bond is known as the ionic bond. Clear? Okay, this is all about the octet rule. Now let me move to the next topic, that is the Lewis dot symbol. Lewis also proposed that an atom can be represented by their valence electrons by dots. That is known as the Lewis dot symbol. There is a simple notation to represent the valence electrons in an atom. That is known as the Lewis dot symbol. If I am taking any example of any atom, we can represent these atom, their valence electrons by dot symbols. For example, if I am taking lithium atom, right? Lithium having the atomic number of 3 and its electronic configuration is 2, 1, right? So its valence number of electrons is 1. So we are representing the lithium atom as lithium having 1 dot over it, which represents the 1 valence electron present on the lithium atom. Similarly, I can represent beryllium as 2 dot, right? Because it contains 2 valence electrons. Beryllium as 2 dot. What about carbon? Carbon. Electronic configuration is 2, 4, right? Atomic number is 6. Electronic configuration is 2, 4. It contains 4 valence electrons. So I am representing the valence electrons by 4 dot over here. Then nitrogen. 5, right? 2, 5 is the electronic configuration of nitrogen. So 5 dots represent the 5 valence electrons present in the nitrogen atom. Similarly, so on. Clear? This is the Lewis dot symbol of simple atoms or elements. Clear? Okay. Now, what is the significance of a Lewis dot symbol? If we are giving any Lewis dot symbol of any atom, we can find out the how many valence electrons are present over it. For example, if we am taking any example, okay, sodium having a 1 dot over it, it represents that sodium having 1 valence electron. So, by finding the Lewis dot symbol of any of the atom, we can find out the valence of the particular atom and also group valence of the element. These are the significance of the Lewis dot symbol. Clear? Now, there is a simple rule to find out the Lewis dot structure of different molecules. These are the major rules to find out the Lewis dot structure of molecules. The first rule is calculate the total number of valence electrons. Calculate the total number of valence electrons by assuming the octet, which means each of the atom present over the molecule is assuming that they will follow the octet rule. So, we are finding the total number of valence electrons of each combining atom. Then, exception is there. If the hydrogen atom is present, we will take it as the duplet. Duplet means 2 electrons, right? Then, what about the second rule? Calculate the total number of valence electrons for all the combining atoms. Calculate the total number of valence electrons for all the combining atoms, V. Then, if the atom contains any positive charge or negative charge, there is a separate rule to calculate the V, total number of valence electrons for the atom. If the given atomic compound is anion, we will find out the V by adding unit negative charge over it. Clear? I will explain with the examples, no need to worry. Then, if it is having polyatomic cation, which means positive charge, right? So, in order to find out the total number of valence electrons on the polyatomic cation, we will find the valence electrons by minusing or taking the difference between the unit positive charge. Clear? Then, after finding the total number of valence electrons, we will going to find the total number of bond pair electrons, that is equal to total number of electrons divided minus V. T minus V will be the calculation of bond pair of electrons. Then the final step, you have to find out the lone pair of electrons by taking the difference between total number of valence electrons minus bond pair of electrons. Clear? Okay, these are the major steps or rules we have to find out the Lewis dot structures of molecules. Now let us see the application of these rules to find out the structure of different molecules. Okay, first example is hydrogen. If I am taking hydrogen, how we can calculate? Okay, this is the hydrogen molecule. First we have to find out the total number of valence electrons, right? What about the first rule? You have to find out the total number of valence electrons by assuming that all the atoms obeys octet rule. If in the case of hydrogen, it will obey duplet rule, right? So, here 2 hydrogen atoms are present. So, I am taking 2 into 2, where 2 represents the duplet. That is equal to 4 electrons, right? Then, what about the total number of valence electrons here? V, which means 1 hydrogen atom contains 1 electron, right? For 2 hydrogen atom, it is 2 into 1, that is equal to 2. The next step, you have to find out the number of bond pairing electrons, right? The number of bond pairing electrons Bp is equal to T minus V. T minus V, here it is 4 minus 2, that is equal to 2, right? 4 minus 2, that is equal to 2. From the bond pair number of electrons, you can identify that how many bonds are forming. If the electrons are 2, it means that it forms 1 bond. If it is 4, it means it is 2 bonds and so on, right? 2 electrons represents for 1 bond. So I can say that 1 bond is present over here in between 2 hydrogen atoms. Clear? 1 bond is formed between 2 hydrogen atoms. Then what about the lone pairs? You can find out the lone pair of electrons by taking the difference between these valence electrons, V minus BP, right? V minus BP. Here V is 2 and BP is again 2. 2 minus 2, that is equal to 0, which means that in the case of hydrogen molecule or H2 molecule, there is no any lone pair of electrons. So I can draw the Lewis dot structure of H2 molecule as, I will write here, this is our one hydrogen, this is our another hydrogen. This will form one bond between these 2 hydrogen atoms, right? So I am taking one bond in between and there is no any lone pair of electrons. So I can represent this H2 molecule as HH. Clear? Now the second example, that is F2 molecule. Again, you have to calculate the total number of valence electrons, V, bond pair of electrons and lone pair of electrons, then find out the structure of F2 molecule. For example, if I am taking F2 molecule, I am assuming that all the 2 fluorine atoms obeys octet rule, right? So the total number of electrons T is equal to here, T is equal to 2 into 8, that is equal to 16, right? 2 into 8, that is equal to 16 electrons. Then what about the valence electrons? In the case of one fluorine atom, it is having 7 valence electrons, right? So in the case of 2 fluorine atoms, I am taking 2 into 7, that is equal to 14. Now we have to find out the bond pair of electrons by taking the difference between T minus V. Bond pair of electrons BP is equal to T minus V, that is equal to 16 minus 14, that is equal to 2. 16 minus 14, that is equal to 2. Whenever you are seeing any 2 electrons, it represents one bond, right? It represents one bond. So we can say that there is one bond existing between 2 fluorine atoms, right? One bond is existing between 2 fluorine atoms. Then what about the lone pairs here? What about the lone pairs here? We have to take the difference between V minus BP, right? So I am taking 14 minus 2, that is equal to 12, which means that 12 number of lone pair electrons are present here. 12 number of lone pair of electrons are present over here in the case of F2 molecule. So that you can draw the structure of this F2 molecule as, okay, this is our F2 molecule. One bond is present here, right? So I am representing here. Then representing the lone pair of electrons. Okay, these are the number of lone pairs. As you can see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 lone pairs of electrons and one bond pair of electrons existing between 2 fluorine atoms. So this will be the Lewis dot structure of F2 molecule. Clear? Then the next molecule is ozone molecule or O3 molecule. Again, you have to find out the total number of electrons T, assuming that all 3 oxygen atoms will obey octet rule. So I am taking here 3 into 8, right? 3 into 8, that is equal to 24 electrons. Then what about the total number of valence electrons here? For one oxygen atom, it is 6 electrons, right? 6 electrons is the valence electrons in the case of oxygen atom. If you are taking 3 oxygen atoms here, the valence electrons will be equal to 3 into 6, right? That is 18. 3 into 6 is equal to 18 electrons. Now you have to find out the total number of bond pair of electrons by taking the difference between T and V. So I am writing here bond pair of electrons is equal to 24 minus 18, that is equal to 6 electrons. How many bonds are present over here if it is having 6 bond pair of electrons? I have already mentioned that if you have 2 electrons there, it will represent the 1 bond. If you are having 6 electrons, it will represent 3 bonds, right? So it will represent 3 bonds. Then, now we have to find out the number of lone pair of electrons by taking the difference between V and BP. So I am taking here lone pair of electrons is equal to 18 minus 6, that is equal to 12. Which means that in the particular structure of O3 molecule or ozone molecule, we can have 3 bond pair of electrons, 3 bond pairs and 12 lone pair of electrons. Now I am going to draw the structure of O3 molecule. Okay, this is our structure, right? One oxygen is here, one oxygen is here, and one oxygen is here. How many bonds are present here? 3 bonds, right? So, which means that any one of the oxygen atom will possess double bond, right? Double bond. So, I am taking here one of the double bond. Here it is one single bond, which means that 3 bond pairs are present. Now, we have to find out the lone pair of electrons over there. We have to fill the lone pair of electrons over there. Here in this particular case of oxygen, it lacks 6 electrons, right? 1, 2, 3, 4, 5, 6. 6 electrons plus these 2 bond pair electrons, it will obey octet rule, right? What about here? Here it is 2 plus 2, 4, and again 2 electrons are deficient. This will be the 2 electrons, which represents the valence electrons or lone pair of electrons. Then what about here? 1, 2, 3, 4, 5, 6, 7, 8, right? Now you can calculate that lone pair of electrons here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is the total 12 electrons, right? This will be the Lewis dot structure of ozone molecule. Clear? Here is another example to calculate to find out the Lewis dot structure of the molecule. The first one is carbon dioxide. Again, according to the rule, you have to find out the total number of valence electrons, right? How many atoms are present over here in the case of carbon dioxide molecule? 1 carbon plus 2 oxygen, right? Total of 3 atoms are present, and we are assuming that all the 3 atoms, 1 carbon and 2 oxygen atom, will acquire octet rule. So we are taking here 3 into 8, that is equal to 24 electrons, right? 3 into 8, that is equal to 24 electrons. Then what about the total number of valence electrons here? If I am calculating V, for 1 carbon atom, it is having valence electron of 4, right? Then for 2 oxygen atom, it is 2 into 6. So I am taking here 4 plus 2 into 6. How much it is? 16, right? 2 into 6, 12 plus 4, 16. Then you have to find out the bond pair of electrons. BP is equal to T minus V, that is equal to 24 minus 16. That is equal to 8 electron, which represents 2 bond. (24 minus 16), it is 8 electron, which represents 4 bond, right? 1 bond represents 2 electron, for 4 bond it is 8 electron. Now you have to find out the lone pair of electrons, taking the difference between V and BP. You will get 16 minus 8 is equal to 8, right? 16 minus 8 is equal to 8, which means that the particular structure contains 8 number of valence electrons and 4 bond pairs, right? Now I am drawing the structure here. Then one more point you have to note that if the atoms having the electronegativity difference, you have the point that the central atom must have the least electronegativity. So if I am taking here in the case of carbon dioxide, carbon will be the central metal atom. So I am taking here oxygen. Oxygen. How many bonds are forming here? 4 bonds, right? Which means that there will be 2 double bonds. Then now we have to fill out the lone pair of electrons. Here it is 1, 2, 3, 4. 5, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7, 8. 8 lone pair of electrons and 1, 2, 3, 4. 4 bond pair of electrons. This will be the structure of carbon dioxide molecule according to the Lewis dot symbol. Clear? Then what about the next? N2 molecule. Again, the same rule, you have to calculate the total number of electrons T, assuming that they are forming the octet rule. So if I am taking 2 nitrogen atom, it will form 2 into 8, 16, right? 2 into 8, 16 electron. Then what about the total valence electrons here? For 1 nitrogen atom, it will possess 5 valence electrons, right? So I am taking here 2 nitrogen atom, it is 2 into 5, that is equal to 10 electron. Then now you have to find out the bond pair of electrons by taking the difference between T minus V, that is equal to 16 minus 10 is equal to 6, right? 6 electron, which represents the 3 bond, right? 3 into 2, 3 bond. Then what about the lone pairs here? Lone pairs means V minus BPs, right? So 10 minus 6 is equal to 4. So in the particular structure of N2 molecule, there will be 3 bond and 4 number of valence electrons. So now I am drawing the Lewis dot structure of N2 molecule. This will be the structure. 3 bond pair, right? This is the 3 bond pair. Then one, two, three, four. 4 lone pair of electrons are possessing here. If you are calculating the total number of electrons here, for this particular nitrogen atom, it will form 1, 2, 3, 4, 5, 6, 7, 8. It follows octet, right? Similarly, here also 1, 2, 3, 4, 5, 6, 7, 8. It will also form in the octet rule, which means that here is the mutual sharing of electrons happens, which means that this is the example of a covalent bond. Clear? Now, here is the next example for you, that's about the water molecule. Again, find out the total number of valence electrons by taking the octet rule. Then, here you have to note that this is the 2 hydrogen atom. In the case of hydrogen atom, we are focusing on the duplet rule, right? So, 2 into 2, which means duplet. 2 into 2 plus 1 oxygen atom, it is possessing 8 electrons, right? We are assuming that they are possessing 8 electrons. So I am taking here 2 into 2, 4 plus 8, that is equal to 12 electron. Then what about the total valence electrons here? In the case of 1 hydrogen atom, it possesses 1 valence electron, right? Then for 2 hydrogen atom, it is 2 into 1 valence electrons. Plus for 1 oxygen atom, it has 6 valence electrons. So I am taking here plus 6. 6 plus 2 is equal to 8. Then by taking the difference between these two, we will get the bond pair of electrons is equal to 12 minus 8, that is equal to 4. 12 minus 8, that is equal to 4, which represents that this particular structure contains 2 bonds. Now, you have to find out the lone pair of electrons by taking the difference between V and BP. The lone pair of electrons is equal to V minus BP, that is equal to 8 minus 4, that is equal to 4. Which means that in the particular structure of water molecule, it contains 2 bond pairs as well as 4 lone pair of electrons. Clear? Now I am going to write the structure of this particular structure. That is, okay. This is a structure in which these are the 2 bonds formed between oxygen and hydrogen. Then what about the lone pairs here? 4 bond pairs, right? 4 lone pairs which is present over the oxygen atom. So in total it will form, for hydrogen atom it is 1 plus 1, 2, complete the duplet. Again this hydrogen also it is completing the duplet. Then for oxygen it is 1, 2, 3, 4, 5, 6, 7, 8. It completes the octet rule, which means that this will be the complete Lewis dot structure of water molecule. Clear? Now let me move to the example which contain cation or anion. if there is any charge, what will be the structure? Same rule you have to follow. First, you have to find out the total number of electrons by assuming duplet or octet. Here it is 1 nitrogen, right? For in the case of 1 nitrogen, I am taking 1 into 8 plus 4 hydrogen atom, it is having duplet, 4 into 2 plus 4 into 2. How much it is? 4 into 2, 8 plus 8, that is equal to 16 electron, right? That is equal to 16 electron. Then, what about the total number of valence electrons here? In the case of 1 nitrogen atom, it contains 5 electrons, right? Then for hydrogen atom, it is 4 into 1, again 4. Then I am taking here 5 plus 4. Then, when discussing about the rules to write the Lewis dot structure of molecules, we mentioned that if they have any positive charge over the atom, that unit positive charge you have to be taken as the minus or the negative, right? So I am just taking the difference here, minus 1. Clear? Which will equal to 5 plus 4, 9, minus 1, that is equal to 8 electron. Then, now you have to find out the bond pair of electrons by taking the difference between T and V. That is equal to 16 minus 8, that is equal to 8. 16 minus 8 is equal to 8 electron. 8 electron, which means how many bonds are present there? If it is having 8 electrons, 4, right? 4 bonds are formed between the molecule. Then you have to find out the lone pair of electrons. Lone pair of electrons is equal to, take the difference between V and BP, it will form 8 minus 8. 8 minus 8, that is equal to 0, which means that this particular structure does not contain any lone pair of electrons. Hi Aditya, which point I want to repeat? This example, okay, fine. Whenever you are calculating the or find out the Lewis dot structure of the molecules, there is some rules you have to follow. The first rule is that you are assuming that all the atoms present in the particular compound or molecule is having an octet configuration. So if I am taking here, in the case of NH4 molecules, it is taken that the nitrogen will contain 8 electrons, then it will follows octet rule. So I am taking here, for 1 nitrogen atom, it is 8. Then, there is an exceptional case for hydrogen that it does not obey octet rule, but it obeys duplet rule, which means that it contains 2 electrons. Here it is 4 hydrogen atoms are present, so I am taking here 4 into 2. So that we are calculating the total number of electrons as 1 into 8 plus 4 into 2, 8, that is equal to 16 electron. Now the second step is that you have to find out the total valence electrons. In the case of nitrogen, it contains 5 valence electrons, right? Then 5 valence electrons. For hydrogen, it is 1 valence electron. For 4 hydrogen, it is 4 valence electrons. Then the point you have to note that if it is having any charge over it, if it is a positive charge, you have to take the difference between that. So I am taking here 5 plus 4 minus 1 is equal to 8. Then in order to find out the bond pair of electrons, you are taking the difference between these total number of electrons minus total valence electrons, that will equal to 16 minus 8 is equal to 8, which represents that for 2 electrons it represents 1 bond, then for 8 electrons it represents 4 bond here. Then the next step you have to find out the lone pair of electrons by taking the difference between V and BP, that is equal to 8 minus 8, that is equal to 0. Now we are going to draw the structure of NH4 plus. If I am taking the structure here, this will be the central metal atom. Nitrogen is the central metal atom having the least electronegativity. Nitrogen is taking here, then 4 hydrogen atom, right? So I am taking here 1, 2, 3, 4, forming 4 bonds, right? This will be the structure, and there is no any lone pair of electrons for this particular structure. 1, 2, 3, 4, 5, 6, 7, 8, right? 8 or 4 bond pairs are present over here in the case of NH4 plus ion. So I am taking here. Then there is a question will be arising in your mind that what about these positive charge? There is a point to note that if you are having any positive charge over the atom, it represents on the central metal atom. So I am taking the positive charge here over the central metal atom. Clear? This will be the Lewis dot structure of molecule. Clear? Now the next structure is NO3 minus. That is a polyatomic anion. Okay. Again, the same rule you have to repeat. Find out the total number of valence electrons, assuming it follows octet rule. Here it is 1 nitrogen plus 3 oxygen atom, total 4 atoms, right? So, okay, total number of electrons is equal to T is equal to 3 plus 1, 4 atoms are present, right? So I am taking here 4 into 8, that is equal to 32 electrons. Then what about the total valence electrons? For 1 nitrogen atom, it contains 5 valence electrons. So I am taking here 5. Then for 1 oxygen atom, it is 6 electrons. If I am taking 3 oxygen, it is 3 into 6, right? So 3 into 6, how much it is? 3 into 6, 18 plus 5, this is equal to 23, right? Electron. Now we have to find out the bond pair of electrons by taking the difference. 32 minus 23, how much it is? Minus 23, how much it is? Hi Aditya, anyway, congratulations. Prepare well for the JEE advanced exam. Yes, I am from South. Okay, what is the answer here? 32 minus 23. How much it is? Is there any mistake in the calculations? You have to find out the total number of electrons. If I am taking NO3 minus here, for nitrogen atom, 1 nitrogen atom plus 3 oxygen atom, total 4 atoms, right? 4 atoms are assuming having the octet rule. So I am taking here 4 into 8, 32. Then total number of valence electrons. What about the nitrogen? It having 2 into 2, 5, right? 5 valence electrons. Again 5 plus 3 into 6. Then you have to, there will be the mistake happened by me. There is a minus charge is present, right? So you have to add minus charge. Total number of unit negative charge over here. Okay, you have to add plus 1 here. Then how much it will become? 23 plus 1, 24, right? So by taking the difference here, you will get answer is equal to 32 minus 24, that is equal to 8 electron, which represents 4 bond, right? 4 into 2, 4 bond. Then what about the lone pair of electrons? The difference between V minus B, V minus BP, that is equal to 24 minus 8, that is equal to 16. 24 minus 8, 18, that is equal to 24 minus 8, that is equal to 16, right? 16 electrons. 16 lone pair of electrons are present in the case of this particular structure of the compound. Now I am going to draw the structure of this particular compound. If I am taking here, the nitrogen will be the central metal atom having the least electronegativity. Then 3 oxygen is present here, right? So I am taking here any one of the oxygen here. How many bonds are present here? 3 oxygen, right? Total 4 bond, right? Which means that any one of the nitrogen oxygen bond is double bond, right? Then total bond pair is equal to 1, 2, 3, 4. Then what about the lone pairs here? 16 number of lone pairs, right? So I am taking here 1, 2, 3, 4, 5, 6. Again 1, 2, 3, 4, 5, 6. 6 plus 6, 12, right? Again here 1, 2, 3, 4. 6 plus 6, 12 plus 2, 14 plus 2, total 16 electrons are in the case of lone pair. Then 4 bond pairs. This will be the Lewis dot structure. Then the question arises that where will be the representation of this minus charge, right? We can just represent that this is a total of minus 1. Then in order to find out the exact position of negative charge or positive charge on an atom, we will be going to the next topic, that is the calculation of formal charge. Clear? Okay, fine. Now let me move to the next topic in order to find out the exact position of negative or positive charge present on each atom, that is the formal charge calculation. What do you mean by the formal charge? Okay. The formal charge of an atom in a polyatomic molecule, it is defined as the difference between number of valence electrons of the atom in the free state and the number of electrons assigned to the atom in the Lewis structure. Okay, no need to worry. There is no any explanation for the definition of the formal charge. There is a simple calculation formula to calculate the formal charge. It is given as formal charge on an atom in a Lewis structure is equal to total number of valence electrons in the free state minus total number of non-bonding electrons, or the lone pair of electrons minus half into total number of bond pair electrons. Let us see by examples. Okay. If you have taken the example of ozone molecule, this will be the structure of ozone molecule. So you can see here, I am giving the representation or giving the numbers of different oxygen here. This is the first oxygen, this is the second oxygen, this is the third oxygen, right? Now we have to find out the formal charge of each of the oxygen atom present in the ozone molecule. So if I am taking this oxygen atom, I will represent this as oxygen 1, right? What is the formula? Formula is that first one, you have to find out the total number of valence electrons in the free oxygen atom. How much it is? What is the total number of valence electrons in the free oxygen atom? Oxygen having 6 valence electrons, right? So I am taking 6, that is the valence electrons. Then take the difference between the number of lone pairs in this oxygen atom. In the case of this oxygen atom, I can say that here, in the case of oxygen, there is 2 lone pair of electrons, right? 2 lone pair of electrons are present in the case of oxygen atom. Okay, 2 lone pair of electrons are present in the case of this oxygen atom. So I am taking here 6 minus 2, 6 minus 2, then minus half of total number of bond pair electrons present in the first oxygen. Here you can see that in the case of first oxygen, how many bonds are present? 1, 2, 3, 3, right? 3 bond pairs are present. 3 bond pairs means total how many electrons? 3 into 2, 6 electrons, right? So I am taking here 6. Then what will be the formal charge? 6 minus 2, 4. 4 minus 3, that is equal to plus 1. Right? Okay. Plus 1 will be the formal charge of the first oxygen present in the ozone molecule. Then what about the second one? Yes, Nandu, it is useful for your board exams also. This chapter is very important for JEE Mains as well as JEE Advanced, and also for your board exams. Then what will be the formal charge of second oxygen here? The same rule, right? I am representing the second oxygen as O2 here. Then the first step is the total number of valence electrons present in the oxygen molecule, right? So I am taking here again 6. Then What about the total number of lone pairs here? Total number of lone pairs here. As you can see here, total 1, 2, 3, 4. 4 lone pairs are present, right? So I am taking here 6 minus 4. 6 minus 4. Then half into bond pair of electrons. How much bond is present here? In the case of this oxygen, it is having 2 bond pairs, right? 2 bond pairs or total of 4 electrons. So I am again taking here, it is 4. Then it is equal to 6 minus 4, 2. 2 minus 2, that is equal to 0. 0 will be the formal charge on the second oxygen atom. Then what about the third oxygen? I am representing it here as O3. That is equal to, again, total number of valence electrons present in the oxygen atom. 6 minus. Then what about the lone pairs here? As you can see here, in the third oxygen, it is 1, 2, 3, 4, 5, 6 electrons, right? So I am taking here 6 minus. How many bond pair electrons are present here? 2 electrons, right? 2. So 6 minus 6, 0. Minus 1 by 2 by 2, that is equal to 1, right? 0 minus 1 is equal to minus 1. Therefore, minus 1 will be the formal charge of third oxygen present in the ozone molecule. Clear how to calculate the formal charge? So we can represent the ozone molecule by their formal charge as, here it is plus 1, right? So I am taking a positive charge here. Then for here it is 0. Then for here it is minus. Representing plus minus. Representing plus minus. This will be the structure of ozone molecule according to Lewis dot structure, including their formal charge. Clear? Now, what is the importance of finding the formal charge of an atom? We can say that resonance you have already known, right? We can write the structures of different compounds. You can change the double bond here or here, right? Both the structures are right, but according to the formal charge calculation, you can say that if you are having more than one resonance structure, the one structure will be more stable, having the smallest formal charge on it. The smallest formal charge on the atoms will be the most stable one or the lowest energy structure. Clear? That will be the importance or significance of the calculation of formal charge of each of the atom present in the molecule. Clear? Now, in the beginning we have studied about the Kossel-Lewis approach. Then we move to the octet rule calculation, right? What do you mean by the octet rule? Even though they predict the stability of the atoms by using octet rule, but they have some limitations, right, or drawbacks. Let us see what are they. First one is that the incomplete octet, which means that some of the molecules which are also having less than 8 electrons is found to be stable. For example, if I am taking here BeCl2, right? BeCl2. This will be the structure of BeCl2, which means the total of 1, 2, 3, 4 electrons. 4 electrons are present on the central atom beryllium. According to our octet rule, it will not be stable, right? But it is found to be that BeCl2 molecule is also stable, which is against our octet rule. Hi Nandu, my name is Surya. Okay, then what about the BF3 molecule? Again, BF3 molecule. This is the structure, right? BF3. In the case of BF3 molecule, total 6 electrons are present on the central metal atom, which is also against the octet rule, which is having the incomplete octet. What about AlCl3? Again, Al, Cl, 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 right? Again 6 electron. This is the one of the major limitation or the drawback of the octet rule. Even though some of the molecules does not have any 8 electrons, it found to be stable. Then what about the second one? Just opposite to this, right? It will follow expanded octet, which means that some of the molecules possess electrons more than 8 electrons. That is the expanded octet. The examples are given here, PCl5. I am taking the example here. Okay, this will be the structure of PCl5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which means that the central metal atom phosphorus in the PCl5 molecule possesses 10 electrons. More than 8 electrons, right? That is the expanded octet. According to the octet rule, it fails to explain the stability. But while studying the chemical experiments, you can say that the PCl5 molecule is also stable, even though it is expanded octet. Clear? Now, the next limitation of the octet rule is that the odd electron molecules, some of the molecules possess odd electrons, which means either 1 electron or 3 electrons. Odd number of electrons are present, right? For example, if I am taking the example here, NO molecule, right? Nitric oxide. Here the nitrogen atom possesses 3 electron, which is the odd electron, right? Then also it is stable. Then what about the NO2 molecule? This will be the structure of NO2 molecule, which means that the central metal atom nitrogen present on the NO2 molecule having 1 electron or the odd electron. These are the one of the major limitation of the octet rule. The next term is that this theory does not account for the shape of the molecule. What will be the shape of the molecule? He fails to explain the shape of the molecule. Then, as I mentioned earlier that in the case of octet rule, he has studied that the octet rule is based on the inertness or the inert gases, right? Which means that noble gases does not undergo any chemical reactions. But in further practice, we can say that some of the noble gases like xenon and krypton, they will form chemical reactions or react with oxygen and fluorine to form certain compounds, right? For example, XeF2, KrF2, XeOF2. Which means that in order to predict the inertness of the noble gases, the octet rule fails. Clear? Yes, I am from Kerala. Okay. Now here is some practice questions for you. The first question is, which of the following has odd electron? Which of the following has odd electron? In order to find the odd electron, first you have to write down the Lewis dot structure of the compound. Okay, by calculating all the structures of these particular examples, you can say that only the one, option 2, ClO3 possesses odd electron. While calculating the total number of electrons, you will get it is 28 electron. Then for valence electrons, it is 25. Taking the difference between these two, you will get the bond pair of electrons, which means 3 electrons. Only 2 electrons will form the one bond. So I can say that there will be one bond between the atoms possessing one odd electron. One bond with one electron. So option 2, ClO3 will be the correct answer here. Clear? Okay, here is the next question. Which of the following molecules obeys octet rule? Again, to draw the Lewis dot structure, by taking here you will get that NCl3. Okay, total here 1, 2, 3, 4, 6 plus 2, 8 electron. For nitrogen it is also 1, 2, 3, 4, 5, 6, 7, 8. In this particular compound, you can see that all the atoms, including nitrogen and chlorine, follows octet rule, which means option 3 will be the correct answer here. Clear? Okay, now here is the last question from this session. Find out the formal charge on the central nitrogen atom present in N3 minus, that is the acid ion. According to the rule, you have to find out the Lewis dot structure, then find out the formal charge. What will be the answer? Option B, right? 1 will be the answer. So, this will be the particular structure of the Lewis dot structure of the acid ion N3 minus. You have to find out the formal charge of central atom, right? This nitrogen. You have to find out the formal charge of this nitrogen. So, how we can calculate the formal charge? The formal charge is equal to total number of valence electrons on the free atom. If you consider the nitrogen atom, the total number of valence electrons in the nitrogen atom is 5, right? So 5 minus how many number of lone pairs are present in the case of this nitrogen. You can see here there is no any lone pairs, right? Which means it is 0. So I am taking here 0 minus 1 by 2 into number of bond pair of electrons. How many bond pair of electrons are present here? Total 4 bond, right? Therefore 8 electrons. 4 into 2, 8 electrons. So it is here 5 minus 0 minus 8 by 2, that is equal to 4. Which means that formal charge on the central atom, central nitrogen atom in acid ion or N3 minus ion is equal to 1. Which means option B is the correct answer. Clear? Okay, this is all from my side for today. So far we have discussed about the formation of chemical bond, why they are forming chemical bond. We formed going through the Kossel-Lewis approach of the chemical bonding. We studied about the octet rule, then find out the Lewis dot structures of different molecules. Finally, we studied about the calculation of formal charge on the atom, right? I hope it was clear for everyone. Now, again, there is a gentle reminder for all of you about the All India test series. This is the All India test series which is provided by the Infinity Learn for JEE Main Session 2 and JEE Advanced. There is a special discount for you for the 2,999 having the coupon code of U250 off. So don't miss it. Okay, anyway, thank you so much all of you. I hope it was clear for everyone. And tomorrow, maybe in the Monday, I will come to the another topic that is about the ionic bond and the bond parameters. So till then, bye bye all of you. Take care. Thank you so much.